Hello everyone, myself Karthik. I am studying in Sri Venkateswara College of Engineering, Bangalore. Today's subject is data structure. Topic is dynamic hashing with lifted trees. Introduction to dynamic hashing. Dynamic hashing is a method used to manage hash tables dynamically. It allows for efficient insertion, deletion, and searching of keys. The primary goal is to reduce collision and maintain performance. Understanding hashing. Hashing transforms input data into a fixed size string of characters. A hashing function maps keys to indices in a hash table. It is a critical for quick data and storage. Limitations of static hashing. Static hashing can lead to performance degradation with varying data sizes. It suffers from the problem of fixed size tables which can overflow. Collision in static hashing can lead to increased lookup times. Definitions of static hashing. These problems can be avoided by using techniques that allow the number of buckets to be modified dynamically. This is called dynamical hashing. There are several types of dynamic hashing. We will learn about extendable hashing and linear hashing. First, we must learn about hashing index. What is dynamic hashing? Dynamic hashing addresses the limitations of static hashing. It allows hash tables to grow and shrink as needed. This adaptability keeps operations sufficient even with your fluctuating data sizes. Introduction to leafless trees. A leafless tree is a type of a binary tree used in priority queues. It maintains a specific structures that allows for efficient merging. The leftist property ensures that the shortest path to a null node is always on the left. Combining dynamic hashing and leftist trees. The combination encases both collision resolution and dynamic. Leftist trees can maintain bucket lists in dynamic hashing. This allows for efficient handling of collision through tree operation. We can see here the picture of hash functions, keys, and hashes. Dynamic hashing operation, lookup operation. Keys are hashed to locate their representative buckets. Searching within the buckets is optimized using leftist trees. This results in faster retrieval times even with many collision. Performance analysis. Dynamic hashing with the leftist trees provides average cases constant time for operation. The complexity of insertion and deletion remains low. This combination reduces the likelihood of collision effectively. Space complexity. The space complexity of dynamic hashing is generally zero, and leftist tree can help keep memory usage efficient. This allows for expansion without significant overhead. Space complexity. Memory space needed by program consists of two components. A fixed part needed for instructions, space, bytecode. A simple variable space, constant space, etc. A variable part dependent on the particular instance of input and output data. Comparison with other hashing techniques. Hashing is a comparison of hashing, and dynamic hashing is a more flexible. Other methods like addressing can be less efficient in high load second scenarios. Dynamic hashing with a lifted trees offers a balance between speed and spaces. Real world applications used in database for efficient record retrieval and management. Implemented in memory management system for dynamic allocation. Beneficial in a caching mechanism where quick access is essential. Challenges and consideration. The complexity of implementing dynamic hashing can be challenge. Ensuring balanced lifted trees requires careful management. Performance can degrade if the hash function is not well designed. Future direction. Research is ongoing into optimize hash function future. Combining other data structures can enhance performance. The exploitation of adaptive strategies for varying overloads is promised. Summary of key points. Dynamic hashing with a lifted trees provides a robust solution for hash table management. This the combination allows for dynamic caching and efficient collision solution. Understanding and implementing these concepts can greatly improve data handling. Summary of key points. Dynamic hashing with lifted trees provides a robust solution of hash table management. The combination allows for dynamic and efficient collision resolution. Understanding and implementing these concepts can greatly improve data handling. Future directions. Research is ongoing into optimizing hash functions future. Combining other data structures can enhance performance. The exploration of adaptive strategies for varying workload is promising. Challenges and consideration. The complexity of implementing dynamic hashing can be challenged. Ensuring balanced lifted trees requires careful management. Performance can degrade if the hash function is not well designed. Reload applications used in database for efficient record and management. Implemented in memory management system for dynamic allocation. Beneficially in a caching mechanism where quick access is essential. Comparison with other hashing techniques. Compared to static hashing, dynamic hashing is more flexible. Other methods like open addressing can be less efficient in high load Dynamic caching with lifted trees offers a balance between speed and space. Complex space complexity. The space complexity of dynamic hashing is generally zero. Lifted trees can help your memory usage efficient. This allows for expansion without significant overload. Performance analysis. Dynamic hashing with lifted trees provides average KS constant time for operation. The complexity of insertion and deletion remains low. This combination reduces likelihood of collision effectively. Lookup operations keys are asked to locate their respective buckets. Searching with the bucket is optimized using lifted trees. This results in faster retrieval times even with many collisions. Deleting in dynamic hashing. Delete keys are removed from their respective buckets. If bucket becomes too empty, it may trigger a merge. Lifted trees may manage the remaining keys efficiently. Insertion of dynamic hashing. New keys are asked to find their appropriate bucket. If a bucket extends a certain threshold, it triggers a split. Lifted trees can be used to manage the overflow efficiently. Thank you so much for watching my video.